Welcome Space Nerds! ExoMars just did a correction burn, so this week we are going to do a recap on the mission. ExoMars is a two-part mission. The ongoing first part consists of an orbiter, the Trace Gas Orbiter, and one lander, called Schiaparelli. The second part is expected to blast off to space in 2020, consisting of the ExoMars 2020 surface platform and the ExoMars rover. The mission was initially called Mars Exploration Joint Initiative and was a collaboration between ESA and NASA. It was first supposed to fly on top of a Soyuz frigate, but NASA proposed to use the Atlas launcher. This move significantly changed both technical and financial settings for the mission. ExoMars would have to lose weight to fit in the Atlas rocket with the NASA probe. In 2009, ESA secured a Proton-M rocket as a backup launcher for the mission. Then, in 2012, due to budget cuts, NASA terminated its participation in ExoMars. Finally, on March 2013, ESA and Roscosmos signed a deal for full partnership. Roscosmos provides two Proton-M rockets with the upper stage Breeze-M, as well as the descent and landing modules for the rover. The orbiter will include two Russian instruments, and all of the scientific results must be intellectual property of both agencies. The Trace Gas Orbiter will work as a telecommunications relay for 8 sols after the Schiaparelli landing. Then, it will aerobrake for 7 months into a circular orbit to do science, and speaking of which, it has Nadir, an occultation for Mars Discovery, or NOMAD, which has 2 infrared and 1 ultraviolet spectrometer. The Atmospheric Chemistry Suite, which has 3 infrared spectrometer channels. With this, we will have the most extensive spectral coverage of Mars so far. And if you want to know more about spectroscopy, Jared did a great episode on that. And moving on, the Color Stereo Surface Imaging System, or CASIS, is a color stereo camera that will be used for building accurate digital elevation models of the Martian surface. And finally, the fine-resolution Epithermal Neutron Detector, or FRIEND, is a neutron detector that can provide information of the presence of hydrogen in water form or hydrated minerals, 1 meter below the surface. This will benefit future missions because, first of all, the TGO can serve as a telecommunications relay for landings, then the digital elevation models will help to choose future landing sites, and of course, if FRIEND finds water ice deposits, as you can imagine, that will be a very useful information for future manned missions. Then, the Schiaparelli lander is a lander that will serve as a test for the 2020 landing mission. It's equipped with a non-rechargeable battery that sadly will last for 2 to 8 sols only. It will land on the Meridiani Planum during the dust storm season, which is really awesome. And it's not just a lander test, it will do some science as well, like the characterization of a dust-loaded atmosphere, measurements of a dust-rich environment on the surface, then it will measure the wind speed and direction, humidity, pressure and surface temperature, and finally the first measurements of electrical fields at the surface. Alright everyone, I hope you enjoyed this episode. If so, please like and subscribe, and have a great week!